our study session, one study session item for tonight that is our to discuss Inglewood water, taste, odor, and hardness. And we have Director Van Rye and Operations Director Zach Alabassi here to present on this subject. Director Van Rye.
Thank you, Mayor Pro Tem and Council. Like you said, I'm here tonight to just give an update on some of the progress that we've been making over the past couple years relative to taste, odor, and hardness. Now I'm sure the council knows and we know that one of the most common feedback points that we get from our customers is how the water tastes and sometimes the odor and definitely the hardness associated with it. And so we've been working on a multi-pronged approach to address that taste, odor, and hardness, and wanted to come back with some of the results and just a summary of some of the things that we're doing. Before we get going, I wanted to highlight in the audience Josh Roach, who's our O&M Deputy Director, and Josh is sitting behind me, and Zach Alabassi, who's the Treatment Manager. And a lot of this work and a lot of this effort is because of their knowledge and understanding of the treatment process and how to make the appropriate changes so that we end up with a better product coming out of the plant and coming out of the systems that we have. Okay, so we'll roll right into it. So if we go back from a historical perspective, taste, odor, and hardness has been an ongoing issue. Customers, as long as I've been here, but I've heard customers say this has been a challenge for decades. And so I think it's one of those things that the City of Inglewood water customers have really just grown to accept the taste, odor, and hardness, and we decided to take a more concerted effort to fix some of those things and try to make for a better product. Some of the things that come out of taste, odor, and hardness issues, while they're not water quality related issues relative to meeting EPA and State of Colorado regulations, they could often cause a customer to feel concerned about the water. So they're things that indicate to a customer maybe there's something wrong, when in actuality, our water meets federal and state regulations. We test it repeatedly. We make sure that we always have the contaminants below the levels of their any regulatory level, that we have the right level of disinfection and things like that. So we're testing on a monthly basis throughout the system to ensure that that's the case, and on a daily basis coming out of the plant. Part of the challenge with taste, odor, and hardness is it comes from multiple locations. So it's not just one thing. We don't just fix one thing and then the issue goes away. Taste and odor, they're caused by one set of issues. The hardness is caused by another set of issues, but they end up working together to impact the aesthetics of the water that our customers receive. So if you look at the picture, you'll see on there the South Reservoir. And what we've determined is that one of the most significant contributing problems to our taste and odor issues is coming from South Reservoir. So if you look at that picture and you look kind of halfway across, there's a line that runs through the O and the U of South. And that's a curtain wall. And what that curtain wall, and so basically what it is, it's a curtain that hangs in the pond. And what it's designed to do is keep the solids that end up in that pond. And those solids are essentially what come off the treatment process. So we take anything that's in the water, the treatment process through the many steps, pulls those contaminants out, and then we send it to the South Pond, where we then pull those solids out, send them through our filter press, and then ultimately haul them off. Well, that curtain wall is supposed to separate the solids area from the cleaner area that's not impacted by those solids. And if you look at that drawing or that picture, you can see how it's gray to the east of that curtain wall. And that's basically where the solids have gotten so full into that reservoir, because the rate at which we take them out versus the rate at which we put them in has been, the rate they go in has exceeded the amount we've taken them out for decades. And so the pond has become so full that it's essentially pushed the curtain wall over, and then the solids are now in the area that's supposed to be that cleaner water area where there's no solids there. And what happens is that water then decants to the north, so it moves back into the system to the north, where you see that reservoir where it says flow from south to north reservoir, and then that goes right back into the plant for treatment. And so what happens is we end up with this short-circuiting effect, and that's because the solids haven't been pulled out at the rate that they should have been for quite some time, to the point where now the South Pond is just creating this ongoing challenge that just builds on itself. Well, it took taking the time and energy and investing in staffing resources, and frankly, this is where Zach's expertise as a chemical engineer, years as working in water treatment, decades working in water treatment. He led the process to start to look step by step through the process to figure out what's happening from a constituent perspective, from a chemical perspective, to try and isolate where the issues are coming from, which is where this south reservoir issue of that short circuiting of those solids really presents one of the biggest challenges that we've run across, and that's because of the work that he's done. And so if you look at the last bullet of historically, we just didn't have the in-house resources. We didn't have the investment in those resources. I think everybody understands that up until 2020, the plant or the utility was largely underfunded, and we were far behind. And so I think for years the staff were working with what they could, realizing there wasn't enough resources, enough staffing, and if we're not pulling out the solids fast enough, they just tend to build and build and build, and that's part of what creates that system. So what are we doing today? We're looking at the taste and odor in all of our streams. So we're looking at not just the South Reservoir issue, but we're looking at it from a city ditch perspective, from a Union Avenue. We're also looking at ways that the city ditch water is actually better source water quality. And so we want to figure out ways to move more of that water directly into our water plant, so that we're accessing that water that's at Chatfield. This is, again, part of the rationale for closing the pipe from Chatfield all the way to the Allen plant, is so that you don't end up with, today we have situations where along those open channel sections, where entire neighborhoods of street drainage and runoff end up in our source water, and then that puts just more pressure on the plant to remove those contaminants, constituents. And a lot of hardness comes from urban runoff, and so the urban runoff is actually getting into the plant in those locations, is actually causing a lot of that problem. And so that's why we have the project, which is City Ditch, to close to close the whole system from Chatfield to the Allen plant in one pipe. And then we continue to look at ways to operate the plant more efficiently. This is, again, another one of the expertise that Zach brought to the city was each one of those processes, you dial them in so that they work together as an entire plant. Whereas if they're not completely dialed in, what they'll do is they'll somewhat fight with each other. And so if you put too much of the wrong chemical in at the wrong time, it'll fight against another part of the system. The end product still meets all water quality regs, but what it does is it can compound the taste and odor issues as part of that process. And so his deconstructing the processes of the plant has helped optimize the chemical dosing throughout the plant to make sure that we're achieving the best quality water with the least amount of those residual compounds and effects that come with chemicals working against each other. So from a source water perspective, we talked a little bit about this. We're actually doing the water that comes from City Ditch is actually just a better source water quality. So what we've looked from 2023 to 2024 was how can we use more City Ditch water, less. When it says river, that's Union Avenue. So that's where our pump station is, at Union Avenue. So if we shift that blend, we actually end up with a better result for the the treated water, because the source water is in such better shape. Also, another thing that Zach reminded me of, if we use city ditch, it just costs less because we don't have to pump it up the hill. So it actually saves $17,000 a year just in pumping costs. But if you look at near the bottom where it says ozone system, if you recall, in the last year or so, we purchased an ozone trailer, and that ozone is designed to address those taste and odor compounds, which are MIB and geosmin. Those are products. Those are essentially compounds that come from algae, and when we get algae blooms in those reservoirs or in the solids in the south reservoir, that's what continues to contribute to those taste and odor issues. And so ozone knocks that down. And so we figured out that putting the mobile ozone trailer right where that, I'm going to go back to the previous slide, right where that decant, where it goes from the south reservoir to the north reservoir, that's where we park the ozone trailer now. And we hit that water with ozone to knock down those constituents. And you can see what happened. The constituent levels go from 66 nanograms per liter down to 5.1, or you can see how dramatically it knocks down those just based on the results of what we're seeing now going back into the north reservoir. So now we've taken those constituents out, which then breaks that cycle of just continually short-circuiting those compounds. Additionally, at Union Avenue, we use powder-activated carbon to work on taste and odor. Those are the carbon filters, and powder-activated carbon is actually what helps to remove those. So we utilize additional levels of powder-activated carbon and optimize that at the Union Avenue pump station and try to drive that down. But really, this comes down to source water. The more we use source water that's got just better water quality, the better it is throughout the entire system. So as we think about the South Reservoir, one of the projects that you've heard us talk about is is changing out that belt filter press, which is well past its useful life and can't keep up with the rate at which we put solids in versus take solids out. We're switching that out with a centrifuge, which is a much more efficient process and essentially spins the water out. And if you recall, over the last couple of years, we've hired a contractor who brought in a mobile trailer who spent 6 weeks out there just gaining us some volume, giving us some breathing room in terms of volume in the south settled pond so that we could order our own centrifuge and replace that belt filter press with a new centrifuge. Centrifuge is a tried and true technology. There are centrifuges at SPR that have been operating since the 90s. They've centrifuges back there used over there since the 70s. So this is a really tried and true process. So we're moving away from that belt filter press to the centrifuge, and we're at the point now where the construction contract is where we're at, and as soon as we receive approval from the council for the construction, we'll get this centrifuge installed. Keep in mind, we ordered the centrifuge last year. It takes more than a year before it gets delivered. We expect delivery on that in May. And so once that gets installed, we think this will be up and running by about August. And that'll give us that ability to crank out water and crank out solids out of that south settled pond much faster. And return the volume back to where it was supposed to be, move that curtain wall back over. So let's move into the distribution system. So part of what we're also looking at is how the water gets all the way through the pipes in the streets to your house and ways that we can improve that. And whereas we used to just once a year do flushing, which actually is coming up, we do that every April, and that's because during the winter, demands are low, so water doesn't pull through the system with as much velocity, and so you get sediments that drop out in the water, and that's from the inside of the pipe and things like that. And so we flush that out, and you've all gotten the notices on that. That's when you see fire hydrants going. We're flushing all of that iron and things like that out to freshen up that water that's been there for the winter. One of the other things that we have looked at or that we installed were tank mixers. So our two overhead tanks, the big white tanks that you see on the northwest side of town and the southeast side of town, those used to only not have mixers in them. And so the pipe that goes up to the tank supplies the water to the tank. And then when we draw water back out of it, it comes down through the same pipe. And what happens is operators want to keep those tanks full. And the reason you want to keep them full is in case there's a fire or something like that, we want to make sure that the tank always has water in it. The problem when you keep them full is, and you don't draw them up and down, is they go through what's called stratification. And so you end up just putting new water in the bottom, and the new water comes back out. The new water goes back in the bottom, and the new water comes out. And so you end up with this stratified water in the tank, where the water that's near the top doesn't ever get the chance to come back out. And so what tank mixers do is they basically cause that to all mix together. So that when water comes in, it mixes, and then you don't end up with water that stays in there for a long period of time. So just putting in those tank mixers has helped from a tank perspective, which then improves the taste and odor as it moves throughout the rest of the city. Additionally, one of the things that we do is we investigate every customer complaint now. So if we get a customer who says my water doesn't taste right, we send our staff out there. We try to investigate whether it's something going on with their home system, plumbing system, or if maybe they're on the end of a street and there's a fire hydrant. We'll put those into a more frequent rotation of flushing out. So instead of just flushing once a year, we have locations throughout the city now where we know that there's a low demand on that pipe, and we just go out there and we flush it every now and then to put that demand and pull the water through again, so that the water doesn't get old. The water age in the pipe doesn't get too old. So hardness. Let's talk about hardness a little bit. And this is really this comes down to really that work of changing the source water. And you can see what the effect is when we stabilize that source water and we use more of the city ditch. And the blue line is 2024, the yellow line is 2023. And so in the yellow line, when you see those big spikes, that's likely associated with a runoff storm, like a thunderstorm and runoff, or maybe a snow melt or something like that, where you have a significant amount of runoff coming into the Platte. But just by changing that blend from 47% to 82%, you see the average hardness drop from 225 milligrams per liter down to 149 milligrams per liter. So we're not all the way there yet, but we've made a lot of progress just by optimizing how we're utilizing our source water, because we know the water that's coming from Union Ave pump station has all that influence from urban runoff that creates hardness, that puts minerals in the water, and then that then translates to the white spots and the things you see on your shower head and things like that. That if we can get that knocked down primarily by just how we blend and optimize the source water, then that means less infrastructure to install for softening or something like that in order to maybe get it down to an ideal goal where we want. So that was a 34% reduction by making that change. So where do we want to be from a hardness perspective? Be great to be under 100. That if we got to 100 or just under 100, that would be really, that's the kind of water that I think people are striving for. Right now we're at about 149. And so we're going to continue to work on optimizing that source water and how we can, again, closing city ditch and getting rid of that influence of that street runoff. That will help this. How we time utilizing that water versus the Union Avenue water, that helps this. And essentially, we can get to a point with changing source water, and then we'll get to a point where we can't probably bring it down any lower. And then at that point in time, that's when we look at other technologies, like maybe a softening process or something like that, to knock it down a little bit further, depending on the cost-benefit ratio of moving from 149 down to 120 or 100. But instead of trying to treat 350 or 2 or 300, we're now treating that last part, which means we're building the right size system, as opposed to building a too big a system and then optimizing things afterwards. So the way we're methodically going through it sometimes seems like it's taking a while. But we're doing this because there's so many pieces to taste, odor, and hardness that all interact with each other, that we're trying to deconstruct it and go through it step by step to ensure that the end result is the optimized result for our system as it is right now, but also the most cost-effective way to manage the system before we say, and now we need to add this capital investment to make it a little bit better. So our plans moving forward, you can kind of see where we've been and where we're moving. We started off by actually just, paying much more close attention to these compounds and really starting to try and dig into what's causing the issues. And I think we've done a lot of work, and Zach and his staff and Josh and his staff have really put a focus on this because we hear from the community and we're trying to get this better. You see some of the technological improvements that we've made, some of the optimization improvements. That south reservoir, when we can get the sludge out of that, we can get that back to the way it was originally supposed to be designed and operated. We think that's going to have a tremendous positive impact. And then we'll continue to talk with our customers. We'll continue to do updates like this. We anticipate that maybe around once a year or something like that, just give a progress update on what we're doing. You see in 2025-26 algae treatment. So taste and odor is a result of algae and the compounds that they give off during the summer. So when late summer, early fall, almost all the water providers in the Front Range have challenges with taste and odor when they have algae blooms in their reservoirs. And so when we're looking at our north reservoir and our south reservoir and seeing a lot of algae there are technologies that can help mitigate the algae and knock those levels down, which then should correspondingly knock down that MIB and geosmin as well. And then ultimately, we're still working towards piping City Ditch. That project is a bit behind schedule, and that's because the process we were working on with the contractor that we were working with, we could not get the pricing to a point where we were comfortable and we thought it was acceptable. And so we did what's called an off-ramp from the CMGC process and have repackaged it, and is now out for bid with the construction community. And we expect that we're actually anticipating, hopeful that we'll see pricing come in where we're saving millions of dollars off of what those original numbers were. And so it's one of these things where we're always paying attention when we utilize collaborative delivery or those types of other contracting methods to make sure that whatever the pricing is, it actually does still represent a value to us. When we can't get the numbers to come down right, it causes a delay in the project, but frankly, the amount of money that we think we're going to save by causing that delay is worth taking that step. And so, again, it's up to the market. The market might come back and say we were wrong, but it's worth seeing what the market says on that. And that's the summary of where we're at from a taste, odor, and hardness perspective. So I'm here to answer any questions that you might have.
Thank you, Director Van Rye. And I will note that Councilmember Neunenkamp has now joined us online. Welcome, Councilmember Neunenkamp. And appreciate this. Great news, I think, with the decrease in the hardness over the last year. And I'll open it up now to council for any questions. Anyone want to kick us off? Okay, Councilmember Wright.
Thank you. Thank you for the update. I think it's a lot of work that everyone has done, and I appreciate it. One of my questions is, in piping City Ditch, a lot of that, aren't we doing IGAs with Littleton and developers that they're developing by Mineral and Santa Fe? So are they paying for that portion or the portions in some of those areas?
Yeah, so thank you for the question on that. And the answer is yes, they pay for it. And so essentially what happens, and this has happened throughout the length of City Ditch, is the ditch, when it was built in the 1860s, followed the contour of the land. It followed one of the it's a very flat ditch, and that's because they're trying to get the water as far northeast as they can. Well, when a development comes in, it's usually in the way. And so our position is that we'll work with you to move it and pipe it and put it in the alignment that makes the most sense for your development. But that's a cost that you're going to incur as a developer and then we get a pipe ditch out of it. So those two large developments down there, we've worked with them over the last 3 or 4 years as they've been bringing in their development plans to optimize the ditch location for their development, but also get us a more straight line pipe ditch that they end up paying for. So the city does not pay for that. We have that as a condition of moving the ditch.
Okay, so I guess my question is what area, I need clarification on what area the city's paying for that we're waiting for pricing and correct contractors and stuff.
So there's 3 reaches. Well, actually there's 4 reaches. There's a small reach down in that area that that we're going to cover the concrete ditch. We're just going to put a cover on it so there's no outside influence into it. But that's a really small stretch of the project. So what we have is reach 2, 3, and 4. Reach 2 is essentially right around, it's basically due east of like where Breckenridge Brewery is. The ditch is in a pipe until right around that location, and then it crosses to the east under Santa Fe, and then it returns to its original ditch. So there's a reach through there that goes around this small little lake that will be piping through there. It goes in front of the school there, St. Mary's. Is that right, St. Mary's? Yes. And then it actually goes back into a pipe. And so that's reach 2. Reach 3 is north of that. We have another area where it goes back from a pipe into its original ditch location. And that's where, is that Slaughterhouse Gulch? Is that reach 3? So Slaughterhouse Gulch, that area, there's some old flumes that we're working with the city of Littleton to from a historic preservation perspective, but ultimately that area, this open ditch, will end up being piped. And then reach 3 is actually the north part, basically the intersection of Windermere and Bellevue, right behind Bellevue Park. It comes out of the pipe there, and then weaves around Bellevue Park, and then ultimately ends up at the Allen plant along. Basically, there's a flume that goes over Big Dry Creek, and then that area that is immediately east of the South Settled Pond. So all of that will get piped, and then it gets piped right to the point where it then connects into the Allen plant. And so the only areas that will still be, they won't be in a pipe, but they'll be covered, are that part way to the south. It's going to be a closed system, but it's already a concrete channel, so it's not like it's a concrete box basically, and we're putting a cover on it. And then that flume that crosses Bellevue, Big Dry Creek, we'll do the same thing. We'll cover some kind of we don't know if the original flume is going to have a carrier pipe that goes in it, or if it's going to be some kind of a cover on it. And the reason why is that's a cost thing for us right now, because that's a really long, big directional bore to get from one side of Big Dry Creek all the way to the other side. And we think that we can save a few $1 million by just utilizing that existing infrastructure and closing it. And then at some point down the road, when the water that comes through City Ditch maybe needs to become pressurized, that's when you'd look at doing that work. But part of this is making sure that we're not doing we're not making improvements that are way too early for when they're going to be utilized. Okay. But also making sure the improvements that we're making are the right ones, so that when we make those improvements in the future, we're not just going completely backwards on the work that we've done. We try to make it incrementally build on itself. So 3 and 4 are out to bid right now. 2 is actually, we're redesigning it because 2 is right along the railroad, and we've had a challenge in terms of getting the what we think are acceptable property rights by working in the railroad right away. And where we have it in the railroad right away today, it's because the ditch predates the railroad. But as soon as we change that, we lose property rights, and so we didn't think the loss of the property rights on such an old piece of infrastructure was worth So we're redesigning it to stay out of the railroad right away.
Okay. And then one more question, please. And thank you for that.
Sure.
I think it's clarifying because we had big discussions on that big development. So the other is, I know that there were big discussions on dredging. I lost the picture. Where you do the ozoning right now.
Mm-hmm.
So because you use the ozone technology, how often do you have to dredge that area in that pond now? Is it much less, or do you still do that?
No, so we need to dredge that thing for a few years in order to return the volume back to where it was originally designed to be. That's going to take a few years depending on the rate at which we're pulling it out. We're also evaluating the idea of potentially just draining the pond and bringing in front end loaders to pull as much out to really try and get ahead. But we haven't. That one has more logistics associated with it that we're working through. But if we just run those solids through that centrifuge, it'll go a lot faster, but it's still going to take a few years. Once that's established, that volume of that pond is reestablished and the pond is functioning as much more clear water than it is solids, what we'll do is we'll send solids to it, and then a certain amount will build up and we'll dredge them back out, but we'll make sure that whatever rate we're putting solids into the pond, we're dredging them back out and drying them so that we don't end up with this huge buildup that has basically rendered the south pond much less effective than it was originally designed. So several years to start, 2, 3, 4, we don't know exactly, because it all depends on staffing levels and timing and things like that. And then once we get it reestablished, we should never be in this position again.
Okay. Thank you so much. I appreciate it.
Yep.
Councilmember Prank.
Thank you for the presentation and the last answer, because I answered some of my questions. So to build on the answer that you just gave, you said a couple of years once we get the centrifuge going. So
Yep.
Can you give us a sense in the picture where we see the line, the curtain wall, where that should be after a couple of years?
Oh. Okay, so if you look on that line, you see on the west side where it says sludge?
Yeah.
That's the gray solids of the wastewater plant, or I mean the water plant sludge. And essentially that dam is, on the western edge of that dam, it's 20 plus feet tall. And so that sludge is filling that area up to within about 2 feet of the surface of the water. And so there's 10 plus feet of those solids that we want to pull out. And that extends all the way to, essentially you see where it's like a light gray tint where the word reservoir is? Mm-hmm. That's where those solids have moved past the curtain wall into that clear half of the pond. And all of that comes out. So all of that gray is what we're trying to pull out to reestablish that depth of that pond, which is 10 to 15 feet deep. Is that about right? 10 to 15 feet deep.
So the line of where the wall is shouldn't change, but the sludge beyond the wall should come back. Okay.
So what that curtain wall does is as water comes into from the treatment process comes into the pond, what's supposed to happen is those solids are some of them just they float, or they won't settle, but they won't float. They'll just kind of stay suspended. And so what they'll do is they'll move over and then they'll hit the curtain. And once they hit the curtain, then they drop out. And so what that curtain wall is, that physical boundary to get those solids that kind of just stay suspended, because they're not heavy enough to fall out, but they're also not heavy enough to float to the top.
Okay, that's helpful. And then the next question might be a little silly, but when we're talking about chlorine residuals in this presentation, that's used to clean overbloom of algae. Is that correct?
So the chlorine is the disinfection that so before we send the water out into the distribution system, we add a chlorine and ammonia and creates what's called chloramines. And that's essentially the long-term disinfectant of the water as it moves through the distribution system and ultimately moves to your house and into your home. what that's there for is in case there's, any kind of constituent that might create a contaminant to that water system, it consumes that chlorine, that chloramination, that chlorine and ammonia, and that kills that. And so the disinfection component, which is the chlorine and the ammonia, is what keeps the water, once it leaves the plant, free from having some kind of a bacteria or algae or contaminant grow within it. And chloramination water typically lasts weeks. And so we test it, we have to test it on a monthly basis, but chloraminated water, because our system's actually pretty small, we never get to the point where we're pushing the time limit for chloraminated water. So our residuals, once we go out into the distribution system, and even the farthest reaches of our distribution system, they're always right where they need to be. They never get too low. And if they do get low, that's an indication to us, well, there must be something going on, and then we investigate. But we don't have that, we don't run across that problem.
Okay. So when people talk about there being chlorine in the water, it's this.
Yeah, chlorine in the water.
This is not in addition to.
Yes.
Okay, got it.
Yes, that's right. It's the disinfection for the water.
Okay. I think that is all I had for now. Thank you.
Councilmember Russell.
Thank you. Thank you for the presentation. So the city ditch currently, does it come directly into the plant itself?
So we have options. So we can run it directly into the plant, we can run it directly into the North Reservoir, and then we also have to run water all the way to the north to Harbor Gulch. So we own, the city of Englewood owns the ditch all the way to Harbor Gulch where it terminates, and we operate the ditch all the way to Harbor Gulch where it terminates. For our water uses, we can either run it directly into the North Reservoir or directly into the plant, or we can blend the two between City Ditch and Union Ave. And so this is actually part of what Josh and Zach and their staff figured out was there was configuration that was built into those piping systems that was probably put in there in the 90s, right, or earlier, that give us options to do many different ways of utilizing water.
So once we have the ditch all enclosed, will it come directly into the plant then rather than draining into the pond? Or either way, you can drain it into the pond
We
also?
can do either.
Okay.
And so depending on how we're trying to blend or use different water sources, or, it could also be something associated with a water rights call or something like that. We have those options, either run it directly into the plant or blend it with the water from Union Ave or run it into the North Reservoir, which the North Reservoir is just basically a wide spot in the pipe. And so it basically gives us that ability to modulate the flow into the reservoir so it doesn't have to go up and down and up and down. But essentially, we have all those options, and we'll use all those options.
Okay, so it just depends on different things.
Depends on a number of factors, and our strategy is to optimize those factors in a way that produces the best source water going into the plant based on whatever those restrictions might be.
Okay, thank you. And when the ditch was open, did it run along the east side of like both reservoirs?
Yeah, you can see it actually in the picture. So if you look at that, just to the east of the South Reservoir and just to the east of the North Reservoir, that's the city ditch. That's the open city ditch. So we will be piping that section that runs along South Reservoir, and then just immediately above where you see flow from South Reservoir, just right above that, that's the structure that diverts water into the reservoir, and so we'll pipe it to that point.
Okay, all right, perfect. Thank you so much.
It's very small on the screen. I'm looking at Councilmember Camp to see if she has any questions or comments. Nope, okay. Very good, thank you. I do have a couple of questions myself. First of all, on the ozone, I ride my bike by there occasionally, and I've noticed the last couple months the ozone trailer is not there anymore. Is that a seasonal thing, or is it?
That's exactly what it is. It's
Okay.
It's not winterized. So we take it out and then we winterize it so it doesn't freeze. It's not, it doesn't have heating and things like that. Plus, the majority of the time we're trying to use it is during those summer and fall
Right.
months.
That's
and
when
where,
the algae blooms are happening anyway, so it's not as critical. The the other thing on the you talked about short circuiting is I'm just trying to understand how that South Reservoir works. When you say short circuit, you mean the water is flowing back into the North Reservoir without having sufficient time to precipitate the solids out or whatever? Is that what's happening there?
yeah, essentially. So all the solids that end up in the South Reservoir are what's it's what's cleaned out of the source water. So, you get sediment, you get other constituents that might be in the water, some, whether it's the organics, things like that. That's what all the treatment processes pull out, and then they settle down or they get caught in filters, things like that. When we backwash a filter or they settle out somewhere in the plant, all of that gets collected and sent to the South Settle Pond. And so that's all the stuff that we've taken out of the water in order to clean it to drinking water that goes in the South Pond. Well, if that South Pond had its full capacity available, then it would fall out on the west side of the curtain wall. It would become much clearer by the time it gets to the east side of the curtain wall, and then it would head north into the North Reservoir, and then it goes back into the plant. So we keep the water in the cycle. What we're trying to do is keep the solids out of that water. What happens now is that impacted water doesn't have the ability to completely clear out. When it goes into the North Reservoir, it immediately goes straight to where it's a flow back into the plant. One of the things that we've talked about as a future consideration to improve this even further is to put a curtain wall in the North Reservoir that essentially forces the water all the way to the north end of the reservoir, so then it comes all the way back around. It gives it more travel time to get to the plant. And that's probably a future project that we do, I would say, in the next 5 or 8 years or something like that, maybe sooner. But that would be a further optimization that we put in place after we got this part taken care of, which is the solids or what just continue to cycle through. So we pull them all out, and then they just migrate their way back in, and then we pull them out again, and they migrate their way. Not all of them, but a certain amount of them migrate their way back in. So yes, that's what's
Good. Okay.
short circuit.
That's helpful. Now, my final question is just on kind of the subjective experience of taste and odor. We normally run our water through a filter system with reverse osmosis and all of that, but it stopped working a couple months ago, and I took some water out of the faucet and drank it because I needed to drink some water. And I said, Becca, I told my wife, I said, I think this water tastes better than it used to. Is that just my subject, or do you think we're at the place where people are going to start noticing improvement in their subjective experience of the water?
So you see me smiling because that's what we're working towards. And we're actually hearing more and more comments from people saying, I've noticed an improvement over the last year or 6 months or year.
So you're starting to hear that stuff as well.
Yes, we hear that more from when we're talking to our customers out when we're interacting with our customers. One of the most recent places where I heard it a couple times was I gave a presentation to Elevate Englewood, and there were a couple of people who said, I've noticed the water has gotten better. And so those anecdotal, responses and feedback is actually a confirmation that these systematic approaches are actually starting to have an effect.
Yeah, I think it is, and I also my reverse osmosis filter has a little readout on the hardness coming in and the hardness going out, and I have noticed that instead of seeing those, sometimes I would see 350, 400, 450, or even 500. Now I'm seeing pretty consistently down 200 and lower. So I think it's working, and I'm excited about that. And that leads to kind of my final question is, what about communicating this and like, I think part of it is people are gonna start noticing, but it might be appropriate at some point to start pointing it out to people. Do you have a communications plan on, I think even that number, the 33% or however much it was, decrease in hardness, so 2023 to 2024, are we gonna communicate that to the customers?
Yeah, I think we're getting to that point now where, we wanted to, first we had to show a trend, and we had to make sure that the data matched the trend of what we were trying to do. And I think we've got 2 years of data that shows there's an effect from this. We want to bring it to you all because you're the ones that probably hear it as much as anybody. So I think the next steps are communicating this out more broadly. I see this as something that we can communicate through neighborhood nights. We can communicate through potentially, our website, maybe some social media posts. We've got some videos we've been working on to help illustrate this. And we anticipate those videos releasing later on in the spring, which, focuses specifically on taste, odor, and hardness. And so, those we've been working with communications for quite some time to get those videos done, and we're pretty close to releasing them. But I think we're at that point where, it might get people to start to say, well, you know what, actually the water does taste a little bit better. Now, we haven't fixed it everywhere, and we still have work to do. And there are still pieces of this that we're trying to make sure that are long-term fixed. But just hearing that anecdotal feedback from yourself and some of those people at Elevate Englewood, what we hear in them, is really encouraging in the sense that we're on the right track here.
Very good. Any other comments? Councilmember Wright?
Thank you so much. 2 more things. Do we know how much it would cost to go in to the South Reservoir and just take heavy equipment and, like you mentioned, is it dredge? No, it wouldn't. To just pull,
Front-end loader.
just go in and drain it and pull all that contaminated soil and stuff out to just kind of clean it up, and then between using the ozone and doing a massive cleanup, do we have any idea, I guess, do a restart, what that would cost?
Now is figuring out those costs. One of the larger issues is while we have the reservoir drained, where do we send the water? That becomes more of the logistical issue, because the water still has to, we still have to treat the water, and we're still going to be generating solids. And so if we're going to drain the reservoir down, we have to have a place for that water to go that doesn't, create a, and that's part of what we're looking at is if we can drain it to with the potential receiving water or something like that. And we don't have those answers right now. That's where it's not just as simple as you just empty the reservoir and, pull a bunch of, put some front end loaders in there. There's complicated phasing that we have to make sure that we do.
Just can't put a water wall up, huh?
I mean, it's when the staff proposed this idea to me, a couple months ago, I was like, yeah, that'd be great if we could do that, because it would accelerate this whole, it would accelerate this whole centrifuge process and really just get us back so we're not behind the 8 ball on it. So, working on it.
Yeah, and I have a picture in my mind where you're just pulling all that stuff with the water in it. I don't know. My mind.
Yeah, we'd stick it in the drying bed, and we'd have to have it dry and things like that.
Right.
So it'd probably take a little bit longer to dry out because it'll be saturated, but all of that is what we're looking at.
Okay. And then my other question is, with the draining of the hydrants, you do it yearly. Is that posted anywhere on your website or anything, so we're letting people know? Because I think the first thought, and I know I'm going to get calls tomorrow saying, I've never seen them drain the hydrant in my area, that type of thing. So is that posted anywhere where it's scheduled saying, okay, we're going to be in your neighborhood this week, draining your hydrant?
Yes, so every year we work through communications to get it on our website, get social media out. We notify it on the weekly report. We put it everywhere that we can, realizing that we generally get through the whole system in about a week. Is that about right? Week and a half. So we don't necessarily go neighborhood by neighborhood because it's so fast that we end up through the whole system. Now, where we're doing spot work through the rest of the year, that we could probably look at ways that if we're in a particular neighborhood and we're just flushing a hydrant for a period of time, of doing a much more localized. Do we do any kind of notification when we're?
The majority of the reason we do it are because customers have requested it. So
Okay.
it's
So you
come
gotta-
up to
you
the
gotta come up.
microphone, please.
Thank you. I'm gonna bring up Josh Roach, who's got a good answer to this question.
Yeah, good evening, Josh Roach, Deputy Director of Operations and Maintenance. But the one biggest motivating factors for doing that flushing is because we have received calls with issues. We look at that, we investigate that. So we respond to their call, and then we flush that system. And then we take a look at the whole map and find other areas where that would make sense for us to flush that. So the majority of that is because we're receiving calls from those customers. So we'll tell them, yes, we'll be back every month and we'll flush this.
Okay, and they're notified, so
Yep.
they're not calling us saying, nothing was done, so I appreciate that. Okay.
That's correct.
Thank you so much.
Thank you, Josh.
All right, well, thank you so much, Director Van Rye. We have any more sorry, your what? Anybody have any more
Actually,
comments?
do you have something you want to
I
say?
saw your water bottle is in front of the light, so I didn't
It's
see it. I
okay.
apologize.
I've turned it on and off a few
Okay,
times too.
go ahead.
Just to build on a little bit to what Member Wright was asking about. So I'm just curious about the heightened use of the centrifuge when we first start using it. And does that have a long-term impact on the longevity of that tool? And if so, like, then is there more benefit to face the logistical issues of draining the pond and getting us to a good point where we've got more use out of that tool? It's a significant investment for the city, so.
So centrifuges are very, very resilient pieces of equipment. The centrifuges that we have over at South Platte Renew, there's 3 of them in the solids dewatering building. They've been running since the 90s, and it's the same 3 centrifuges. And I think this is right, that we bought them used, and they're actually manufactured in the 70s. So they've been around for decades, and you have to rebuild them and you have to maintain them and things like that. But they are a very, very solid
Okay.
process. So if we move this route of utilizing front end loaders or something like that to pull the water out, the wear and tear on the centrifuge is really actually kind of low on the reason. I mean, there will be some, but these things are pretty bulletproof, as long as you're maintaining them and we're doing the preventive maintenance and things like that.
Okay, and if we don't drain and we're just using the centrifuge, so if we already have pulled 55,000 dry tons, which I have no idea what that amount looks like. So in layman's terms,
I
what
think it's
does,
5,500.
in your presentation,
Oh, I'm
there's a area where it talks that we pulled 550
Oh, yeah,
dry
I'm sorry,
tons
sorry.
out.
Yes.
So
Yes.
for a layperson, what does that look like? And what will it look like once we shift over to the centrifuge? So this is with our old system that we're intending to destroy. So how many dry tons do you think we'll be pulling out in those first couple of years?
So do you happen to know this so I'm gonna turn this over to Zach, because he knows the numbers. The 550 just got us started. There is a whole lot more.
Yeah.
So the 550 took 2 events of using a centrifuge by a contractor. That was probably over a span of maybe, the first year we did it was, we went for maybe a couple of months. The following year, I think we went a little bit longer, we went for 3 months. So they were able to remove 550 dry tons out of the South Reservoir. We did a pond survey, so they go out on a boat and basically they stick the sludge to determine the depth of it. They collect samples, dry them, and to determine how much % solids it has in it. A rough estimate that we have about 2,500 dry tons of sludge in that reservoir that need to be removed. So with the 2 events, we removed about 20%. The one point that I want to emphasize, that removing the sludge is one step that's done by dredging or front loaders. What comes after that is dewatering or drying the sludge. So if we drain the reservoir and go with front loaders and take as much sludge as we can, I think we would exceed our capacity to store that sludge and let it dry just by the sun and the wind. The ozone the centrifuge speeds up that process, where as we take the sludge, that thin sludge, and put it through the centrifuge, it's instantaneous dewatering. So we're taking it from 2, 3, 4% sludge. The centrifuge will process that upward to 20, 30%. And then we put it on the ground to accumulate before we haul it off-site. By the time the trucks show up to take it off-site, it's almost at 40, 50%. So getting rid of as much water as fast as we can speeds up the entire process.
It makes us more efficient. Okay, thank you.
Yeah, so this is Zach Alabassi, who was just here, he's our treatment manager, and you can see why we like having him looking at all the systems, because this is the degree to which he's looking at it and understanding it, and Sean reminded me just that Zach spent much of his career at Denver Water doing exactly this kind of work for Denver Water, and we were able to hire him a few years ago, and as soon as he got here, he started looking at this, and it's that background of decades of experience at Denver Water that I think we're getting the benefit from because of his expertise around this. So we just wanted to make sure that everybody knew that that's Zach Alabassi, the one that's helping us really solve this problem.
Well, thank you, Director Van Rye. Thank you, Mr. Alabassi and Mr. Roach, for improving our water. I know, and thank you to the citizens for waiting so. I mean, we increased rates to deal with this several years ago, and we're just now seeing some results from it, and it's been a lot of patience from the citizens, a lot of hard work from you guys. So we're very grateful for it, and look forward to more in the future. Thank you.
Thank you.